solid alkane onto the shipping casting box.
The question is, was the NAC LWT the only cask, or are there other ones that could be used? At the time that we needed to lay out the schedule, it was the only one. Next slide, talking about our licensing approach with this TN32 cask. This cask is already fabricated and built. It was fabricated under a certificate of compliance number 72-21 and certified to that certificate. It is serial number TN-32 Bravo-81. Fabricated and also and TN also issued the certificate of conformance for that cask. So it meets the general license requirements right now as it sits. Another reason why North Anna is somewhat uniquely poised is that we're familiar with and we're set up to use handle TN32 casks. So, and we happen to know this one is available, and so that's again another reason why North Anna stepped up for this. The proposed license amendment, SNM 2507, is really what we're going to develop, because we're not going to use this cask under the general license, even though it is already set up for use under general license. So we're going to request the NRC under license amendment to modify SNM 2507, which is North Anna's site-specific license, to include TN32 Bravo-81 with certain features and enhancements to allow it to be used under this program. How do we do that? So the Arriva TN is working on developing a design and licensing basis document, which we call the DLBD. And this document will be submitted with Dominion's license amendment request as a proprietary submittal. The DLBD will provide the analytical bases and conclusions for departure from the existing approved analyses in the TN32 FSAR. So I'll explain that. Right now, as I mentioned, this cask has already been licensed. Its analytical capabilities have already been reviewed and approved for use for storage for certain types of fuel. We are departing from those certain types of fuel, so therefore all features of this cask have not been reviewed and approved by the NRC. The design and licensing basis document will address those areas that are new to this cask, such as burn-up, thermal enrichment, those types of analyses that need to take place for the license. The design and licensing basis document will address those differences that are needed to get this cask approved for a site-specific license. The TN32 FSAR will still form the basis for the license amendment, and those analyses that do not change will still exist as they're written in the FSAR. So it's really going to be a hybrid of the TN32 FSAR with the design and licensing basis document, supplementing it, those analyses that need to change to form the complete picture of the TN32 cask for the SNM 2507 amendment request.
Tom,
yes.
You gave examples there.
They are not.
Two things that come to mind are including an analysis of how two things that come to mind is to make sure you include an analysis of how the higher radiation field and higher temperatures will affect the materials of construction of the cask. And also, I'm not sure, is this a license as leak tight or system?
Well, it has a leak. It has an approved leak rate, yes.
Yeah, well, then you're going to have to address the release fractions of the Highburn fuels.
Correct.
Just two items that quickly come to mind. There might be others.
Okay, thanks, Bob. Appreciate that. Bob was just pointing out that there are the the example analyses that are shown in this slide, and they're not intended to be encompassing of all the analyses, that there will be other ones, including what Bob mentioned about the analyses of, since it's not a leak-tight system, even though the leakage rate is extremely small, at least the design leak rate, to include all those components that need to go in for the analysis, which currently exists for the TN32 analysis right now, but we would have to augment that and change it to encompass the Highburn fuel.
I think Bob has a good point on the utility construction. You may also want to consider the higher radiation and higher heat to the polymer fuel. Yeah, that's something.
Absolutely, and that comment was the higher heat and higher radiation source term on the polymer behaviors. So, yeah, the neutron shield. So, and certainly that would be evaluated.
This is the if we look at the TN32 FFAR, that projects the impression that there could be a flex system, but I think you're talking about that specific license. So for that matter, perhaps you are going to use new rec 1867 instead of new rec 1836 as the basis to construct it, to review your current FBAR as a complete package.
Yes, correct. We will look at our FSTAR and include changes to our FSTAR associated with this cap. And the site FSTAR, yes, the site FSTAR, yes. Any other questions? Moving forward, thank you. Other materials included in this design, and this is just to let you know there's items in this cask that are necessary other than fuel. And of course, we're going to have thermocouple lances, and these will all be included in the LAR as well. But the thermocouple fuel assembly interface guide, and so that's going to be a device that sits on top of the fuel assembly and is for all intents and purposes, it's a funnel. It'll help us align the thermocouple lance as it comes down through a 10-inch lid. And you got to make sure it goes right into the guide tube. And so it gives a little bit of play at the top as a funnel. It lines up with the guide tube, and so the thermocouple lance, as it's inserted in through the lid, goes into the proper location. We'll also have some neutron absorber rods, additional hold-down capability inserted in the fuel assemblies prior to storage, so that at some point in the future, if it's licensed for transport, we'll have the adequate poison loading in the cask, or the neutron absorber loading in the cask. And these neutron absorbers look very similar to the absorber assemblies that are used during operation. It's basically a BPRA plate with neutron absorber rods. This is a cartoon here to show the thermocouple lance as it sits in the lid of the cask. And you can see the bold line there represents the confinement boundary, and that boundary goes right up to the outside, or the inner seal of the dual seal. And so this is the confinement boundary layout. Barry Tracy was kind enough to put together this full-scale model he's got on the table here to give a better depiction of how this alignment looks. And it's really a very nice model he's got here. And I ask if you're interested, we could pass that around. You could take a look at it to get a better 3D picture of what this looks like. So, yeah.
Maybe we'll just get see. Could you have somebody go up there and just trace out what the confinement boundary is? Yeah, because I can't see what it is.
Oh, and
It comes through the inner seals and then down the thermocouple lamp and off the other seal.
Okay,
Yeah, it goes from
from the inner part of that seal.
Yeah, your inner part of the seal, down the thermocouple lamp,
It's right here.
And then
This is where the gas is.
to your other interstitial.
This is a spacer that these nuts will hold down the metallic opening of this. And this red part is the pressure.
What is the seal between the thermocouple lance and that metal part, the flange part? How is the lance attached to the flange?
It's braced.
Yes,
The lances.
the lance is.
Come out, like, up here. To the flange.
It's the same instrumentation that's used in core, either PWR.
You have the lance rod here. This is the actual lance that goes into the fuel assembly, and then this is welded here. The rod is, the overshoot is welded in here, and it's also welded in here at the top where the wires come out.
And you see this has really been used in reactors, so all the brazing techniques have been approved and blessed and everything else.
But these are identical to reactor thermocouples.
It's been in operation for over 40 years.
But I can mention like metal temperature, are they attached to the guide tube?
Yeah, these go down into the fuel assembly guide tubes, and they see temperatures, well above.
What I mean, they're attached, don't you?
No, they're not
No,
attached
they-
to the guide tube.
No, they
measure metal temperature, and you mentioned gas, yeah.
measure temperature in the reactor at the top of the core.
No, these are
What I'm saying that,
yeah, the question is, yeah, inside the TN32, you're actually measuring the gas within the guide tube. No, we're projecting that over to the piping.
But you're also getting radiation heat transfer that's going on between those surfaces because of high temperature.
We're not touching the
Well, you mentioned touching the metal or some other applications you have in the reactor internal environment. The question really is for that flange, that interface, or the guide you talked about there. For instance, during OEE, which will occur quite a few times perhaps for the life of the service. So the question there is, whether that overhanging bar would be flattening that flange to cause some kind of say, current issues, or whether you can have a confidence that where your bar is, where your the thermocouple is really going to be after an earthquake event like that. So that is something, I don't know whether you have that in mind in your performance, the criteria as you purchase or you use these particular instruments. So that was the question I raised yesterday. I heard the description but today, well, it was really, I just want to make that observation, whether you had that kind of considerations already.
Okay.
Well, I don't have a direct answer for that, but we can address that, yes. Okay, thank you. Yes.
Yeah, just a follow-up on a couple of questions. So you have validated or verified that the temperature that you will receive, the temperature that you will receive in the thermocouple will be able to be extrapolated to the defined temperature?
That
model in place, basically?
That's what PNNL and is developing right now, is that type of model analysis to basically extrapolate from the guide to gas region over to the plant.
Okay. And, I guess during the submittal, you have to Yeah.
provide some information. Tom, I know that you're only submitting a storage license at this time, but while I have it in my mind, one of the questions when you eventually get to the transportation aspect of this is you've got a long lever arm on this brazed weld is what the fatigue response of that's going to be on and over the road transport. So just keep that.
And you know, we did touch on that a little bit today, Bob. And the question is about fatigue on the thermocouple lamps, and certainly in reactor service, and there's fatigue information on this. So I think we can address that. And in reactor service, they do vibrate quite a bit, many years. So I think we can address that. Oh, one more question. Yes.
Another question. You know, the closures usually are redundant. From looking at this picture, is that still maintained?
I'd have to double O-ring. I'd have to defer to Mr. Creason.
It's a double O-ring, double seal.
So the use of these thermocouple, the way they're laid out, is going to give us the opportunity to integrate from the front end to the back end and talk to our folks across the street a little bit about how these are used in reactor pressure vessels, and make sure we get a little more educated on their use and how they would then apply to the containment of the TN32, just so you know.
Okay. Appreciate that. Thank you.
Well, one point I'd like to make for transportation, because we're not going to more likely rely on that lance boundary as part of the containment boundary for a transportation license. Good.
Yeah. Okay. That's the slide. Okay. Other license amendment request features. This cask is already built, and so there are some non-conforming conditions that resulted in the fabrication process. And so anything that would rise to the occasion that I would want the NRC to look at, we would certainly include those. They've already been evaluated under 7248, so I don't really think they need to be included. But we can't use them as 7248s right now because they were written as a 7248 against the certificate of compliance. So we would have to hold on to those non-conforming conditions until after such time the SNM 2507 was approved and evaluated against that. Or the other option would be to include them directly into the LAR. So we're taking a look at those. We're evaluating which ones, and we know that a couple have to do just with a measurement equipment, probably not in proper calibration, so it was redone. That doesn't rise to the level of something to be reviewed after the 7248. We had those evaluations in place. But I just wanted to let you know that there might be in the LAR an occurrence or two of road certification that was off nominal from what was in the design. We also plan to have a separate set of technical specifications associated with this cask and only this cask under the site-specific license. So one set of technical specifications that apply for 27 TN32s, and then another set of specifications that apply for the demonstration cask. Just because of its unique nature, and to me it seems to be cleaner that way to keep it separate. Which, by the way, is the same format as the Surrey, which we got 5 different designs. Each one has their own set of separate set of technical specifications. Another feature that's currently not in SNM 2507 is a thermal soak period. And while this is not, I don't think this is a difficult leap here. The expectation is that once you load the cask, you're done sealing it, and then you bring it out to the pad. There's no real defined time that you have to move it to the pad, but what I want to make sure that's clear is that after we do the helium admission into the cask, the helium backfill, that there's going to be a period of time that we're doing some initial tests on it. And we want the cask to come to thermal equilibrium, which Certainly, we don't expect to be any more than 3 weeks, but we plan to have it under the what we call our temporary monitor, which monitors the internal portions of the cask, during which time we'll be taking temperature measurements, gas pressure measurements, and cavity gas measurements, composition measurements, while it's sitting in the cask at this time. And after the period of time, after this thermal soak period is completed, then we will do the final leak testing in accordance with the test specs and what I would call button up the cask and bring it up to the cask. So that's not stated anywhere in our current tech specs. I just wanted to make you aware that that is something that would be coming through.
Tom, quick question about thermal equilibrium. What sort of criteria are you using? Is what 7 times 9, 63 thermocouples? So is there some algorithm that you can use to determine when equilibrium is reached?
I'd have to defer to the technical powers here to determine that, but I know that from a field examination, the cask comes to temperature pretty quickly. Okay. And so, I mean, in less than a week, it stays pretty much the same temperature. So, but the fine variations of when we actually get to something that's, how much difference do we expect to see? Maybe thermal equilibrium would be, under 5 degree change in the period there. I'm not really sure, but we would have that discussion. But I would expect that this period would be no longer. Thank you.
There is a question.
Can you just briefly mention again why the leak testing is performed 2 weeks after the given actual?
Well, what we're doing, we're monitoring the cask during that time, but we want to have access to the cask cavity so that we can pull samples to determine what the cavity gas is doing during that period. You can't do your final leak testing before you do that. So you want to do your final leak test after all the initial tests are done, so you bring it to the pad. Post-transfer to the pad, the tech spec monitoring equipment, that is the OP system. The OP is, that's the overpressure system or the pressure monitoring system. We'll install those at the pad like we normally do. This is the tech spec monitoring system. This is identical to the existing North Anna TN32 casks. The one difference is here is that now the pressure monitoring system will be connected to the thermocouple lances. The seals of the thermocouple lances. And so that the overpressure system, pressure monitoring system, whatever you want to call it, will be in communication with the thermocouple lances. So that should there be some type of leak between the seals on a thermocouple lance, you'll see that. And it will indicate at the central learn station. But just like our current casks are set up. And I would also propose that we would have an identical periodic test frequency for the tech spec monitoring equipment. Right now we have to do this test once every 3 years. And I would propose that we would have the same type of test frequency for this particular cask.
So, are you still planning to monitor the pressure within the 2 confinement seals?
Yes, we are.
Okay. In addition to monitoring the pressure between the 7,
well, it's all one. It'll all be one.
Oh, it'll be
It's all communication with one overpressure system. Right. And so the continuous monitoring will see the thermocouple lances and also the other ports. We won't be able to identify which one, but we'd have to take it back and do testing on it should there be a leak. But it's not like we can identify which port is leaking. We have to actually do the testing to figure that out. Or we could do that back at the station.
Okay. So, I mean, there are 7, right?
There's a total of 9. There's 7 thermocouple lances. Right. 7 plus 2.
And plus 2 within the containment seal as well.
Yes.
So you're monitoring 10 locations.
8.
8 locations.
The OP system, they're all tied together, so that's 1. And then there's 7 instruments, that's 8.
Okay.
And they're designed to be isolated so that they could be isolated on the pad.
Okay. All these 7, I mean, these are all part of the confinement boundary.
Yes.
Okay.
Yes.
So, I mean, that's a sort of a major change to this system.
That's right.
Now you have 7, 8 penetration into the confinement boundary.
That's right.
Okay. I mean, it's one of the questions I want to ask. You have to, is your licensing basis changing as a result of modification to the system? I think at the end we can talk about, because I've got a couple of questions on criticality,
Okay.
assumption, and all that stuff.
Okay. And, well, we talked a little bit about what you're getting to, probably not on the same line, but, you know, we want to, part of this approach is in situ cavity gas sampling. You know, we talked about this a little bit last time, and I think even Raj, you brought up at that time about this building that the test building that we're going to place over this cask. Is it part of the confinement boundary? And it made us think a little bit more about how to approach this. And I think really once we open up that seal, that port to gain access to the cavity, while the cavity at that time still has a quick disconnect on it, so there's no escaping of any internal gas. But still, we've opened up that confinement boundary, and so the way I see around it is I think we would seek exemption to 72 for that particular time when we open up that boundary, and showing that and establishing the monitoring that we have in place to for the exemption. You know, for a period of an hour or so that we have to do this test. So I think that what I would expect is that we'd come in with an exemption request to that particular regulation, and that's 128.83 may not be the right regulation. I'm just putting it out there for example. But we'll also establish the monitoring controls within the test area so that we have monitoring in place, even though that we certainly don't anticipate any release whatsoever. We'll have the correct monitoring in place. So, and that's a little bit different than what our approach was last time, but that made us think a little bit more of how we need to, how we might need to approach that. And this is still a work in progress.
Tom, you'll be monitoring through the port that has the tube that goes all the way down to the bottom of the...
This would be the 10th port, so it would have no tube down to the bottom of the gas.
Do you expect... I'm trying to figure out, I mean, the trip found in the email are going to be much heavier than the helium, whether there's going to be any striation of the gases, or whether you'd be better off pulling from the port that went all the way down. Something to consider.
Yeah, but, okay. I would have thought they would have mixed.
Maybe the guys who do the thermal hydraulics will say they're mixed. It's just something to consider.
Good point.
Because you wouldn't want to pull the sample and then have the calculation done. So she's over krypton sitting at the bottom the sample from the top.
What we would have to consider is the volume in the port, because half a liter bomb or a liter bomb may not. Okay, sample bottle.
Much better.
Sorry. Negative pressure sample bottle. Anyways, the volume that's in the pipe may not bring the volume up to the collection point. And I've seen that on other systems that operate.
Well, it's just something that probably should be considered before we go ahead, or you go ahead much further, because you don't want to build a system. You take the samples and find out after you've taken the samples that you've gone through all the trouble and the samples don't have any validity.
Yeah, I think even free helium and air mixes. It doesn't go to the top unless it's confined into a balloon.
Yeah, I was going to say, is there convection going on?
Well, that's what the thermal hydraulic people will have to tell you.
Okay, we'll get that. Thank you. Okay, so talking a little bit more about the in situ cavity gas sampling, it's not currently described in the site-specific license, but we would describe the process and what it would